Okay, we are live. Hi, hello everyone.
Hello.
Welcome to Functional World. Today's meetup is going to be a little different because we are stepping away from Scala just for a moment. And Darek is Scalac's DevOps expert, and actually he suggested today's topic for today's meeting because he knows all too well the challenges that developers face and the wait times for DevOps support. And he knows best the tools that can help you tackle those obstacles and you can work faster and more efficient. And a group of Scala developers at Scalac has already had a chance to test Darek's ideas and share their feedback. So you will be getting a polished set of tips and tricks for today's meeting. So get ready for some practical insights. And that's it from my side. Darek, good luck.
Thank you. Hello, everyone. I would like to invite you to talk about how to handle things in your project without DevOps around. I would like to interest you in some introduction into the Terraform, and then show you some things about the infrastructure as code itself and some tricks that will help you to maintain the project without, let's say, full DevOps support, like it's being from time to time in our projects and companies. So my name is Dariusz Kuczański. I'm a senior DevOps engineer in Scala C. So yeah, that's me. Hello. And what about this talk? What I want to get you to know that first things first, this talk is entry level. If you don't have the let's say experience with infrastructure as code or Terraform or some DevOps stuff, it's great because it's especially for you. Nice to have for this one is to have some basic AWS skills, but it's not a problem if you don't have. This is pretty easy part, and I would like to focus on the developer perspective for this. So yeah, my goals for this talk is for you to understand the main concepts of infrastructure as code, how to use Terraform. I want to show you the stuff. I want you to understand. I want to show you that it's pretty easy to start from the beginning, because of course you can do the complex stuff, but let's focus on the basics, right? So this is the agenda for this. I would like a little bit of intro into the DevOps infrastructure as code and Terraform itself. I want to talk about why does it matter, and then I will proceed to basics of Terraform, show you how to create modules, how to create multi-power envs for that, show you some tips and tricks about this, and then we can have some Q&A sessions. So yeah, looking forward to it. So the introduction to the DevOps IaC, the Terraform, but before that, I would like to go, oh, sorry. Yeah, wrong shortcut. This is always nice. I would like to dive in for a moment. I will give the command, and then we will proceed, because I prepared some live demo for you, and I want to show you how quick and easy it really is. Okay. So we have limited time. The topic is very vast, so I'd like all the stuff, all the basics. I could debate for hours about this, but let's say not this time. If you don't know something about this topic and you want to learn more, you can, contact me afterwards or check the nearest Wikipedia site for some definitions. And from now on, I would like to focus only on the specific tasks. So the concepts, right? In the DevOps, as it is, it's all about the collaboration and automation, right? We can agree on that, I think. The infrastructure as code is about making the deployment process repeatable and more reliable. And the Terraform is the tool that allows you to start from scratch, even if you don't know very much about how to maintain infrastructure, how to create infrastructure resources. So this is also very important, that you need to remember that it's not about the tools, but the mindset itself, right? So why all this matters? Why there's such DevOps different tools and concepts around the development of the software? So because you, as the developers, I think everyone could agree on that you need to wait for the other teams to make the smallest request, changing one tiny line, and you need to wait for approvals or code review, pointing and clicking the same stuff in the AWS console, manual fixes after deployment, use the old resources and version of the libraries and tools, wasted money on unused resources that you forgot to delete, the orphaned one. You are still not in production with your application, but you're already in technical debt. So those are the things that matter the most. And what can we do about this? What should we gain from going into infrastructure as code? We can increase the velocity of development, so you will no longer be blocked by other teams. We can speed up the deployments because they are tested every time you run something new. You got the certainty that things are working, and not that you are changing some things about you didn't touch for a while and it doesn't work. We can build in higher security. We can enable the multi-environments in very easy way. We can get rid of orphaned resources, and we stop wasting time on the same tasks. And in the end, it's all about the money. So yeah, there's a lot of savings in here when we apply all those rules that we want to. So the Terraform. Terraform is a tool made by HashiCorp, the corporation. You may know there are other products like, for example, Vault for secrets management, or any other. It's HCL based, so it's not the YAML or JSON like we used to do stuff in every other tool, but it's still very nice to handle. Terraform has a great community, vast community that's building the providers and the modules for all the cloud providers, let's say, and all the stuff that you want to build with them. How does it work? First, you write the code, right? This is pretty simple. You write the infrastructure as a code. You can use the resources, apply it to the Terraform configuration, which will be stored in the Terraform state file. Then, after you write some code, you can run the Terraform plan, which will show you the changes that are going to be made for the infrastructure. Then, if you reviewed the plan, you can apply it. So nothing's get done until you be absolutely sure what you are doing right now. Okay, so in order to create some stuff, we need the Terraform. It's packaged in every package manager for any operating system that you can use, so it's fine. What are the commands for the basics commands for the Terraform? We can validate our code, we can format it, we could start with initializing the Terraform workspace we are using currently. We can plan the code, we can apply the code, and we can destroy the code. So let's create some stuff. Yeah, so I would like to invite you into the my IDE. And before that, I want to show you that this is pretty much simple. So let's say we want to create S3 bucket inside the LWS, right? So this is the Terraform documentation. For the resource AWS S3 bucket, right? So we got all the documentation with the different variables and parameters that we can use in here, but this is the example usage that we can use, and just copy pasting it, it will work, right? So this is that simple. I got this copy pasted a while ago, so let's go into the directory. Let's export my AWS profile, and what's going on here? We're gonna use the resource called AWS S3 bucket. We can name it my bucket. Let's go with the functional word 2024. This is the bucket name that we're gonna create. Those are some tags that we're gonna attach. So first things first, what we need to do is, if we want to apply this code, we need to initialize the workspace first. So Terraform init. Initializing the backend, right? Initializing provider plugins. It detected that we are using AWS resources, so it's installing the AWS provider with the latest version. This is taking only a few minutes. Yeah, Terraform has been successfully initialized. So we got the code, we got the initialized provider backend, so we can go with the plan. Let's show us the plan. No, let's do this. Okay. So the plan is that it's gonna only create stuff, and the resource is gonna be AWS S3 bucket example, right? I probably didn't save the file. So this is gonna be the bucket name. Those are gonna be tags and other stuff that's not in the defined resource, but are, let's say, default values. Okay, so since we've got the plan, we can apply it with the apply command. This is gonna go with the plan all over again, but with the ability to execute it, right? So we are asked that we want to proceed with this, and we want to, so yes. See, this bucket name already exists because I was doing some tests. So let's change the name and try again. Yeah, this is the curse of live demos. Okay, I think, okay. I need to check if I'm in the correct, okay. Let's go again with this, because I think some things might be. Yeah, I know what's going on. I'm in the, sorry for that. Okay, I know what it is. I didn't save the file because I'm using a different keyboard than normally. So it's the wrong shortcut. Let's be sure. Yeah, here it is. So sorry for that. Like I said, live demos, right? Okay, created resources. So when we go to the AWS, if you would go to the AWS console, the S3 bucket is created, it's there, so great. And now if you want to destroy this, first things, sorry. What happened here? We got some new files created in here. So we got the .terraform directory with the Terraform provider for AWS. We got the Terraform log HCL, which contains the version of the provider that's currently used. We got the Terraform TF state, which is basically JSON with the current state of the things that we deployed, which is very important. And now we want to destroy this. Destroy. So it's going to go again with the plan and show us the changes that it's going to make to our infrastructure. In this case, it's going to remove or destroy our bucket, right? So we're going with yes. Okay, so the same thing would happen if we did something like this. Let's apply. So create this bucket. Let's imagine that we got many resources in the code, and we want to get rid of something. So we don't want to, doing the destroy command and destroy everything. We want to destroy only this resource. So we can remove it and go with the apply again and see what happens. You could also obviously comment the code out. So you see, it wants to destroy it because it's no longer in the code, but it's in the state that it was created and was under the control of the Terraform. Now it's not, so he wants to remove it. So let's go. Okay. From the other hand, we could create something more, let's say, sophisticated. The EC2 instance, right? So we want to create virtual machine. What we got in here is the data block that allows us to pull some information from AWS, from the resources that are currently in there, and we can use it to pass it as a data block inside the resource, so we can, target different stuff from our code that aren't exactly deployed by us for now. We initialize the workspace again, the backend. Let's go straight to the apply without the plan. You see, before initialize, there was only the main TF file. Right now, we got plenty of those because of the initialization and downloading all of the components. It's going to create stuff, so let's allow him. Yes, this time this is the AWS instance with some stuff that we validated. Okay, works like a charm, right? So the EKS Kubernetes cluster, we'll get back to this. This is something that's spinning up in the background right now. So the Terraform states, right? We right now have the local state, like the file on our hard drive, on local disk. So when we are a single developer creating some stuff for us, this is fine. But when you start collaborating or doing things more efficient, we can use the Terraform remote states, which are going to be stored for example, S3 bucket, and also create DynamoDB table, which are going to be our database for the logging file. So if you are working on something, it will create log in the DynamoDB table, and then if someone else will try to apply his changes in at the same time that you are, it's not going to allow this because it's logged, right? So this is a great thing to provide into your project, so you don't step on each other toes and break things, because that's the possibility. The state manipulation. So we got the file with the state. When we create stuff, sorry, but this is the wrong keyboard and the shortcuts are a little bit different. As always. Okay, so for example, we created the EC2 instance here. We got it, so we can check the Terraform, what we got inside the state. We got two resources, our AWS instance, the EC2, and the data block that we created to retrieve the information from the AWS. So we can also check what's inside. Okay. Maybe it's not the time for now for this, but yeah. Because our time is a little bit limited, I would like to focus on the more urgent things right now. So we want to create stuff repeatedly. So we need to build modules. So not to repeat our code itself. Let's say we want to create few S3 buckets, not one, but few. So here we got the module block for our created module. We got its source, we got the bucket name, and how the module itself looks very similar, like in the first time we created S3 bucket, right? So we got the AWS resource, but the only change is that we are passing the variables through the module that we are creating in here, right? We also define some variables, and also we got the file with the name for it. I'm gonna change this just to be sure. As always, initialization, and as you can see, it's initializing the modules. So it's initializing the module that we got locally. It can be module that we're gonna pull from the Terraform registry or GitHub repository, or basically anywhere. If we go with the apply, yeah, it wants, because let's get rid of those. If you look closely, we are passing the bucket name variable, right? We got defined the type of the variable, but we don't have the value for it. So we can create additional file with variables. For this one, it's going to be the bucket name. We can obviously type it ourselves, but the trick for that is to use the var files. So he can use the one variable that we, yeah. That's correct. That's correct. Okay, very nice. So creating modules is pretty easy, very easy to be honest, but there are some pitfalls that we need to remember, like maintaining the custom modules and versioning it. It's also something that I would elaborate in the future. So the Terraform, same code, different environments. Let's say we want to have the same stuff deployed, but on different environments. Let's say dev and production. For example, we can use this module, and let's say the bucket name will gonna be have the environment into the name, right? So yeah. And how to achieve that? We can create folder with envs. Dev vars and prod vars. In prod, the env it's gonna be prod or production. For dev, the env variable will be env. So when you got multiple envs, we want to normally we would have the, like in the ideal world, we would have the separate AWS accounts for dev and production environments. Right now it's only one environment, so we're deploying in the same AWS account, but in real life we would dev var. Okay, so okay, I might mess something up, so it should work like that, but since the time is limited, I would go to the next thing, but let's just say there are gonna be, depends on the environmental file that we're gonna apply to the Terraform, it's gonna have the set of the dev variables or production ones, so creating multiple envs is pretty easy for this. Okay, importing stuff. Let's say you started using the Terraform, you like it, but you already got existing resources, right? So how to handle this kind of thing? Let's go back to the Terraform here, and okay, let's create S3 buckets especially for that. Function world 2024-123. I will copy this quickly. Let's create the simplest bucket. Okay, it's here. There are a lot of different stuff here. So, okay. So how to import those kind of things? Let's go with, okay, let's copy the code. Import, right? main TF, the bucket. We don't need the tags for now. Okay, the only thing we need is to retrieve its name, because I already forgot this one. Okay, let's forget that we got this created. Let's try to create it by code and see what happens. Because basically importing stuff into the Terraform is we need to define the resources like we would like to do this in the first place, but since they are already there, we will end up with, if you can guess, yeah, cannot create the bucket already owned by you. So because it's already existing inside the AWS, we can't create it all over again, right? So if we go and check the Terraform state, it should be empty. It's empty. So getting back to the Terraform documentation, if we scroll at the bottom, we would see the importing section and see how we can import this. Okay, we need to adjust the command. The bucket name will be our word 2024-123, and the bucket is resource name is example. So if we import successful. So if we right now check our state, we will see that the bucket is here. And if we do the Terraform apply all over again, we are going to see that we have no changes because it's already in the Terraform control. So this is very useful for importing the configuration, the resources that we don't have anything, when we don't have anything in the Terraform, but we would like to, right? This is kind of different example because I want to show you that Terraform can be used not only in public clouds like AWS, GCP, Azure, but also if you have the on-prem machines in your data center, you can still use it to create resources and manage them. This is the example of how to create virtual machine inside the VMware cluster. It's also very easy, works the same. So if you need to maintain your resources by code, you can do it also in the private cloud. There's no problem with that. Okay, I want to talk about proof of concepts and all that stuff. Let's say you want to try something on the Kubernetes, right? So the Kubernetes is a little bit complex. It contains of many layers of infrastructure resources, the network, the policies, all the things, and you don't know anything about it, but you would like to use the Kubernetes and you can't use Minikube because, I don't know, you don't have the resources, or you need to test something on multiple nodes. So we can use the Terraform modules for that. When I started the presentation, I did the Terraform apply on the Terraform module. It took 13 minutes to spin up. We got EKS. It's fresh. Let's configure it. Okay, so let's check cube ctl get nodes. Yeah, spinned up 20 minutes ago, 3-node cluster, easy, right? So if we look at the code for this, it's a little bit, but not that much, to be honest, for creating such a complex thing. And if you look closely, we are using the data blocks to retrieve some information from the AWS, and basically we are using the ready modules for the VPC, which is basically network in AWS. So this is taken care of us, and the EKS module that it's setting up everything for us. So you don't need to know anything about AWS, the internal network, and everything. It's done, right? So it's very very cool to build things that you don't have much knowledge about, but you would like to try, or you need it for other reasons. Okay, so those were the Terraform stuff, but I would like to show you the some tools and concepts how to maybe make your work with the infrastructure as code a little bit more easy and fun. So first of all, the driftctl tool, it helps us to identify the resources that we got inside the Terraform. Inside the AWS, but we don't have them inside the Terraform stuff. So let's say I would like to I need to rate limit the CPU because there are too many API requests to the AWS normally, and it's rate limited, so it's not working correctly. But yeah, what it does right now is scanning my AWS account and the Terraform state file that I got on local, right? After that, we got this kind of pretty report that is saying what resources are not covered by infrastructure as code. For example, we got some AWS instances in here. If you remember, we created only one. So if we go to the summary, we get the 56% of coverage for Terraform. Those are resources managed by Terraform. Those are not. Here is 0 because we are doing a good job right now. So you can easily identify what you got inside the AWS, but not in Terraform, and then maybe write the code for it and import it. So this is very useful when you started working with AWS, but then switched into the Terraform, right? Next thing I want to show you is the 3V scanner. This is the security scanner. It have some options. For example, it can scan, it can scan the Docker images from the Docker Hub. Let's say we want to see how's the latest WordPress Docker image is doing. We're going to refresh the database, and we got all the CVEs with the verbosity, with the status, or the oh, sorry. Yeah, this is pretty. Okay. Yeah. So as you can see, the latest version has a lot of different things. Not everything can be fixed, as we know, but yeah, this is kind of it. Another thing that 3V can done is to scan your local directory. It will detect that you got the Terraform files in there, and use the Terraform security database and give you some examples for that. So let's say this is the medium one, that the VPC does not have VPC flow logs enabled. This is something you don't want to do, let's say, but we got some critical things like security group rule allows egress to multiple public internet addresses. Cluster allows access from all over the internet. Those are the things that you would like to know and address them if you are working on live application. And this is, or the public cluster access is enabled, right? So this is another thing that it's worth pointing out, because we use the ready module from the internet, right? Not written by us. We only use it and execute it, and you can see how much security concerns they have. So this is something we should also remember. AWS Nuke. Let's say you got orphaned resources. Let's say you have the dev environment that you want to exist only in working hours during the weekday, not on the weekends, not after hours. So you can use something like AWS Nuke. This is the configuration file for it. It's pretty simple right now. This is my account ID. So when we run it, this is the dry run. So it's not going to delete anything. It's going to scan the whole account with the stuff that we pointed out that should be checked. And then it's going to show us what resources we got currently in AWS and what would be removed during this, right? So there are some IAM role policies attachment and other things. In the end, we're gonna have our EC2 instances, our S3 buckets in every zone, so we can wipe out the account completely. So if we are using the separate AWS account, for example, dev environment, we can easily nuke it from the orbit and forget about wasting money and everything, right? There are two other tools that I would like you to recommend you, the Renovate and Pulumi. I don't have demo for this because setting this up is a little bit more complex, but for example, if you look at Pulumi project, this is the infrastructure as code, but let's say it's SDK for a cloud, right? So you don't have to write the Terraform code and use another tool. You can easily use your favorite or programming language. So if you want to start and don't want to get your head with another tool set and just write some code you are familiar with and feeling better, you can use it, give it a try, and see if it works. The other thing I would like to show you is the Renovate project. What it does is basically integrating with your repository when you have different stuff like different library versions, different Docker images versions, different Terraform versions. So this is constantly scanning your repository and checking if the component you are using aren't released, didn't release the newest version. When it does, the Renovate bot will create PR in your repository with changes for the latest version, and you can do the review. You can write some, you can run some GitHub actions on this, so see if those changes didn't break your application, and then you can just merge it and go with it the easy way, and not without the need to remember that, oh, I got some old stuff that I should take care of. It's gonna be there. So yeah, basically that's all from me right now. So I think we can. I hope you enjoy it, and I interested you in this. So yeah.
Thank you, Darek, for your presentation and your insights. Actually, there are a couple of questions in the chat. This is the first one.
Okay. What do you think about Pulumi, Besom, and Terraform? Okay, Pulumi plus Besom versus Terraform. I don't know the Besom, to be honest, but let's talk about Pulumi versus Terraform. So, from my perspective as a DevOps engineer, I don't recommend using Pulumi inside your project, like in the large project when you are collaborating with other teams or team members, because the fact that you are familiar with the particular programming language and it's easy for you to set up the infrastructure, it doesn't necessarily be as easy for the rest of the team, right? So the Terraform, from my perspective and experience, is much easier to maintain and develop with the teams rather than focusing on different SDKs, let's say. So I would go with that.
And this is the second question.
Okay, my Terraform plan takes over 15 minutes and makes my laptop go crazy. What can I do to improve it? Okay, nice. This is a good question. So if it's taking 15 minutes, I wonder what we are spinning, but maybe something really important. So for example, you can, because the problem is your laptop, right? So you can run the Terraform plan from inside the GitHub Actions, for example, right? So you can use the designed Docker images for that and just run the Terraform plan inside the GitHub Actions after the PR or creating the PR or after merging to master. So using the CI/CD, you can obviously use some remote EC2 instance for that, but yeah, I would recommend going with CI/CD for that.
Okay, so I think that's all the questions from the chat. Are there any other questions? We can wait one more minute. And Krzysztof, you can watch us later on because it will be saved on our channel. Okay, another question.
Can you recommend any affordable cloud providers that allow easy to provision up? Okay, this is a tricky question and a little bit problematic because I know we want to, cut the costs by all means, but sometimes it's not the way. So we can go with, if you want to try this stuff. Let's say you want to try the Terraform, so or any other deployment of the application. You don't need to create large EC2 instances or EKS clusters. You can go with free tier of any cloud provider that is. And this is basically it, because let's say this: AWS, GCP, and Azure are the most common ones, but also the most expensive ones. So I would look at your I would look at some smaller providers like DigitalOcean, Linode, something like that. Oracle Cloud had a nice free tier for some time. I don't know if it's still valid, but might be worth checking that. So yeah, that's it. Or you can, set up virtual machine on your desktop and use the Terraform to provision locally or inside your home lab. So you can, for example, if you have Synology or QNAP NAS or some old computer that you can use for Proxmox or Docker containers, it would be enough.
All right. Any more questions? You can also always connect with Darek on LinkedIn. I've shared a link in the chat. So, well, I think we can finish here. And thank you, Darek, once again for the insights. And thank you all for joining us today. And see you next time in December. Thank you.
Yeah, thank you, everyone. Take care. It was nice hosting you.